Okay, listen up. Okay, look at me. So because of the change to the schedule where Wednesday is so short, I did have to try and find a way, this is too loud again, did have to find a way to try and catch us up a little bit. So what we're going to do today is we are going to kind of go back and forth between the pink and the yellow packet. We will do all of the examples, we'll do all the examples from the homework, so that will reduce the total number of problems you'll be assigned to work on before next class period, so that it becomes manageable, okay? I also think that, honestly, by the end of the period, you'll see that there are a good number of problems in both packets that can be actually completed very quickly once you're getting the kind of the idea of the concepts we're discussing. So here we go. And every class did things a little bit different because I tend to follow your questions. Like getting good at calculus is really about discussing, not me demonstrating. And so in any given class, I follow the questions. And so we sometimes do different examples in different classes. So I don't want to do something we've already done, so just jump in if we're like doing something we have done. Just warn me. So for example, did we do number 2 in the pink yet? In your notes. So grab the pink packet. We'll just do it in the pink. You can just do it in the packet itself. So you can check that off for homework. So here we go. Hold this out of the way. Go over here. Okay, if I remember correctly, we did get far enough in our discussion last time that I should be able to ask you, we're finding the limit as x approaches infinity. So we're right here on our flashcard. We're comparing terms that add. So you should be able to raise your hand and tell me the dominant term in the numerator and the dominant term in the denominator. So raise your hand if you can do that. Hands up. What is the dominant term top? What is the dominant term bottom? Kate Spencer. Really crucial that Kate said negative 4x squared. That's an easy mistake to make. So I write on my paper, you should write the same. Okay, 2 points for Kate for helping. Please raise your hand if you would have said the same had I called on you. Point. Okay, questions? Awesome. Now we just split it up. So we go like this. Questions? Oops, messed up. Sorry, this is cube. And really, I should have done this. My apologies for making you write an extra line. That's going to reduce to negative 1/2. This is really x squared divided by x squared. And then it's all multiplied by x. Like that. Okay, questions about anything? Just because we're trying to catch up doesn't mean I want to rush. I'm just trying to find a way to make it so you don't have so much homework. So we're just doing examples from the homework in class. Awesome. Okay, at this moment now, it's time to just think about it. So we think, okay, x is going to grow forever. You have 3 factors being multiplied. Maroon, green, red. Okay? The first factor never changes. It's always negative 1/2. The second factor never changes either. As x gets bigger and bigger and bigger, you just have something being divided by the same something. That's always equal to 1. So really, as x gets really large, this is going to control what happens to y. So the y value is just getting larger and larger as well. However, that large y value gets multiplied by a negative number, so this limit's non-existent. Basically, we figured out that as x goes to infinity, the y value is going to negative infinity. So we say that the limit is non-existent. Question? Oh, please, Kate. Uh-huh. Um, so I'll ask you a series of questions, Kate. You can just keep marking down the points. Does it feel good to you that we just have to mentally think of plugging into this formula x values that get larger and larger? Okay. However, the formula at the top is a bit too complex, so we use our understanding of power functions to create a easier to understand formula, but it's still the same idea. We are plugging in an x, and the purple formula is calculating the y coordinate. Does that feel good? Okay. So to calculate the y coordinate, all we have to do is think about how this formula works. Well, it doesn't matter what x I pick. What's this always going to equal, Kate? So that's always 1. 1 times negative 1/2 would always be negative 1/2. So really what we have is a formula that's nothing more complicated than negative 0.5 multiplied by whatever x value we plug in. So as we plug in larger and larger x values, the y value is simply going to become whatever the x is, but negated and cut in half. So if I plug in 1,000,000, my y value is going to be negative 1/2 million. If I plug in 1,000,000,000, my y value is going to be negative 1/2 billion. So as x approaches infinity, y approaches negative. I don't know if that helped or not. Okay. Anybody else? Sweet. We also learned that as we're looking at the graph, the right half of the graph does not have a horizontal asymptote. There's no horizontal asymptote for this function on the right-hand side of the graph, because we already figured out that as x goes to infinity, the y value is not approaching a fixed value. Questions? Please. So the idea of non-existent with the limit is, we were trying to figure out, Grace, if as x got very, very large, would the y value actually get really close to, say, 7? And then we'd say the limit is 7. But because the y value is simply getting more and more negative, it's not approaching anything. So the word they chose for that was non-existent. Does that help? Okay. Anybody else? Please. Two different words there, Hannah. So the limit is non-existent, and there is no horizontal asymptote. Here's the big idea. All eyes here, look. Okay, the big idea of both of these homeworks, like one of the big ideas, is to get you very, very comfortable and very, very good at remembering. Whenever you are finding a limit as x goes to infinity, you're also discovering whether or not there's a horizontal asymptote. The process is identical. The wording's a little different, Hannah. Like we would say the limit is non-existent, and you could say the horizontal asymptote is non-existent as well. It kind of means the same thing. They would more typically say there just isn't one. Listen to Hannah. What you said was perfectly correct as long as we are talking about a limit that goes to either positive infinity or negative infinity. That's why you have a flashcard. It's really good, Hannah. Mark down the points every time I say your name. That's why we have a flashcard here that I gave you last time that says, hey, finding a horizontal asymptote, that's just finding a limit as x approaches positive or negative infinity. It's not when x approaches something else. Does that answer your question? Good. Anyone else? Perfect. Okay, so back to here. Okay, so we know that the limit as x approaches infinity is non-existent. We have done this portion of the problem. The homework says for every problem you're supposed to find the limit, and you're also supposed to identify horizontal asymptotes. We've identified that there is no horizontal asymptote on the right. We've got to go figure out what's going on over here on the left. So just like I said to Hannah a moment ago, we just do another limit problem. We find the limit as x approaches negative infinity. Question. Now, we can save a whole lot of writing by just doing it in our head. If the limit is x approaching negative infinity instead of positive, because we are comparing power functions, the dominance does not change. With power functions, it doesn't matter whether x is getting very positive or very negative. You still end up with the same situations. We'd still get here. We're still right there. The only difference is this would say negative infinity instead of positive. Nothing else would change. Questions? Cool. That means nothing changes on the next line either, or the next line, or the next line. That's all the same. There is one difference. Right here. As x is approaching negative infinity, raise your hand if you can tell me what will the y value approach. The answer is either going to be negative infinity, positive infinity, 0, or a number. It's never anything else. So as x approaches negative infinity, here's our formula for computing the x value, the y value. What y value do we get? Hands. All who know. Come on. There we go. Let's go, Riley. Positive infinity now, because here was our formula for calculating the y value. If we're plugging in a very negative number, the two negatives multiply, we get a very positive number. Still no horizontal asymptote, but it is important that you understand the difference, because the class is all about understanding, not doing. So 2 points for Riley. Please, question. The extra stuff here, Riley. I'm having you include this on the homework because I'm trying to build your understanding. On the AP test, you would simply say there isn't a horizontal asymptote. Yeah. Anybody else? Yeah, like I think it's actually quite essential, Riley, that as you are doing the homework, again, you should always think of the homework as being a miniature test. You're testing yourself. So I want you literally verifying that that box makes complete sense. And the best way to verify is for you to see if you can write it before you check it. If you read the answer, your brain's going to say you get it, whether you do or not. So try to write it first, then check the answer. Question? Awesome, let's do another one. We're good there. We've done number 2. Let's go to the yellow packet now. Let's pick up the yellow. We go to number 1 in the yellow. One second here. 2. Okay, number 1 in the yellow. It's the same question. If you read the yellow instructions, you'll notice they are identical to the pink. You're supposed to find the limit of each function as specified, and you're also supposed to determine whether or not there are horizontal asymptotes on both the left and right of the graph. So we're here again. We're finding the limit. It is a limit as x approaches infinity. So we're still comparing terms that add. The new idea on the yellow is this term here is not a power function. This term is a power function. We're still comparing terms that are adding, but we have to understand how they relate to each other. Questions so far? Okay, so I built a spreadsheet to try and illustrate the idea. You obviously don't have a spreadsheet on the AP test, but my hope is this will make your memory quite permanent. So let's go here. So here's different values of x. Different values of x. Then here's the values of 2 times x. And here are the values of 8e raised to the 2x. The gasp I heard someone give was very appropriate. X is supposed to go to infinity. My spreadsheet goes to 47. I don't think very many people would think 47 is close to infinity. But notice the size of 8e to the 2x. Yeah. Impressive. Exponentials grow so fast by comparison that if you're comparing an exponential term to a power function term, the power function is going to win easily. Like it will completely overwhelm the other. And you need to look at the spreadsheet more to make sure that memory sinks in. Anyone have a question, thought, comment? Heard a good joke lately? Luke. So 2x is the power function because you have a variable to a constant. The constant is 1, so that makes that a power function. The e to the 2x, that's the exponential because e is basically the number 2.72. It goes on forever, but we'll round for this discussion. And that's being raised to a variable. So power function is variable to a number. Exponential is number to a variable. Good question, Luke. Anybody else? Okay, so there's nothing different about this problem other than the comparison is new. So we still compare the terms that add, and we get a new limit problem. I assume it's quite clear that this is the dominant term on the bottom. So we end up with this. Question. Cool. We factor. We're going to get this. Questions? So now all that's left to do is to evaluate the limit. So we say, here's my formula for calculating the y-coordinates. We have reduced, kind of simplified that formula to something that's a lot easier to work with. So as x gets really, really big, this item in brown, that's going to equal 1. This will equal 4. So as x gets really, really big, we could say as x approaches infinity, the y value is approaching 4. Therefore, the value of this limit is 4. Questions? Please. Correct. Let me clarify a little bit, Taryn. The comparing idea is only valid when you are analyzing something where the x value is going to grow forever, and it's only valid if you're comparing terms that add. It's not valid for anything else. Good question. They don't test us, like the AP test is not a test that's about limits in great depth. And so this method works really well for the AP test. If we were doing more complicated limit analysis, we'd have to learn some other things. So, anybody else? Awesome. Okay, here's the part I feel like is the hardest for students to remember, so I'm going to see how many of you remember it. Point for Grace. Well done. Just teasing. No, the point is real. I was not trying to be, never mind. Moving on. I need you to remember something. We just found that the value of this limit is 4. But we also found something else. And in pretty much all past years, it's been a real struggle for students to recognize what else we have found. Who knows what else we found? This is a good example of it. Notice how like about half the room is raising their hand, the other half is like, what? I don't know that we found anything else. You have to recognize that when we find this limit, we are finding 2 things, even if they never mention it, because they will test you on it. We have found 2 things, Nate. What else did we find? We found that if we were to look at a graph of this function, this, hold on, I have a little bit. I have to hide my box or people put bottles in it and then you guys don't like them and I don't like them either. It makes me sad. So I don't have very much, but there's a little bit. Oh, it's actually kind of heavy. There must be something in there. Thank you. You can put it by the door. Okay, so here's the formula for calculating the y-coordinate. And if we were to graph that function, we would discover that over here on the right, there is a horizontal asymptote. And the asymptote is at a value of y equal 4. You must memorize that. That's why I gave you a flashcard. When you find a limit as x approaches infinity, they're not going to prompt you. They won't say, oh, what else did you find? The question will be in some other type of wording where unless you have that connection solid, you won't notice that they're even asking. Like it's been very subtle. There are 3 questions on the test I give you for term 1. That test is worth 80% of your grade. That means those 3 questions are worth about 10% of your term grade. Okay? They're about the idea of a horizontal asymptote. You have to get that flashcard down. It's not a complicated idea. You just got to get it memorized. Okay? Question. How many knew that we had found a horizontal asymptote? Show me. Point. Okay. Sweet. Not if it's not lies. Yeah, if you contradict yourself, they're going to take away points. Does that make sense? Yeah, putting too much is no big deal. Multiple choice, however, is just right or wrong. So, yeah. Anybody else? Cool. Okay, for the homework, we do need to identify whether or not there's an asymptote over here. We've got to look and see, is there an asymptote on the left side of the graph? A horizontal asymptote on the left. So we have to find another limit. We've got to find the limit as x approaches negative infinity. So let's do that. Let's move this out of the way. We'll write it over here on the side. So we're now finding the limit. Write this on your paper. The limit as x approaches negative infinity, and we're doing the exact same thing, 2x plus 8 e to the 2x, because it's the same function, we're simply analyzing the function on the left side of the graph. But this is where they are usually successful into tricking many students into choosing the wrong answer. Because if you're just following patterns, you'll pick the wrong thing. If you're not thinking, you'll pick the wrong thing. You have to be thinking. Okay, we've got to think. X is approaching negative infinity. So as Taryn said, we're still allowed to do this comparison. We have to compare and find out which term is dominant. So we've got the 2x. Well, that's going to become very, very negative. 2 times a x value that's becoming very negative will be very, very negative. Questions? we've got to also figure out what happens to that e to the 2x. Here's the part people trip up on. E to a negative number gets very close to 0 very quickly. Like as fast as e grows, it also shrinks. E to the x. Here's the spreadsheet. Here are negative values of x. Here's what happens to e raised to the 2 times that negative value. Look how fast that thing approaches 0. Like when x is negative 30, that's already, I don't know how many zeros, like 20 zeros. Question. You have to memorize that idea. That as x is approaching negative infinity, this exponential right here, the green becomes very, very insignificant compared to the red. So the green here is going to become very, very insignificant compared to the red. Question. So as x is approaching negative infinity, here's my result. I am finding now the limit as x approaches negative infinity of 2x. Raise your hand. What's dominant in the bottom? Hands up. What's dominant on the bottom, Caitlin? 4. How many knew it? Point. So we could say as x approaches negative infinity, please raise your hand. What is the y value approaching now? Hands up. Come on. As x approaches negative infinity, what's the y value approaching? Just use the formula. Like everyone kind of looked at me like, what? Here's the formula. Here's the formula. You're just plugging in numbers that are increasingly negative into x. So x is becoming closer and closer to negative. What's happening to y? Hands up. There we go. What's happening to y as you plug in numbers that are more and more negative, Haley? Approaching negative infinity. It's simply 1/2 times whatever the x is. So if the x is becoming extremely negative, the y is also becoming extremely negative. 2 for Haley. Who else knew? Point. We want to talk about it. I've joked for years that I feel like I'm much more of a math psychiatrist than I am a math teacher, because I don't really teach anything. You just come in, you sit down, you get comfortable, you just talk about it, Just talk about your problems and solve them. So it's really true. Like a demonstration is not going to help you. Like it just doesn't help to sit and watch a guy do calculus problems all day long. Like you just come talk about it. So, questions? It's like trying to watch somebody shoot free throws and get good at free throws. It doesn't work. So, question. Awesome. We discovered there is no horizontal asymptote over here. There isn't one. Please. You don't have to graph, Hannah. All I care is that you understand a few key items. One, if you're so here's how the answers are in the back. If you're understanding that when we found the limit they gave us, the result was 4, check, you're good there. Once you see that, you should be able to say immediately, I know this is true, right here. Like you shouldn't have to do any other work, you should just know that to be true, because they're the same thing. Does that make sense? Then when you find the limit as x approaches negative infinity, as long as you can come up with this idea, that's all you need. Yeah. In class, I'll put a lot of things on the board that aren't necessarily required for the homework, because again, I'm not trying to teach you to do something, I'm trying to teach you to understand something. Does that help? Good job, Hannah. Anybody else? Yeah, you'll see that all year long. There are a few problems where I'll go, line, 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 done. It's just not very common. It's much more common that, again, like the psychiatrist joke, which wasn't very successful since no one laughed. But see, well, you're very polite. It just wasn't as good as I was hoping. I was hoping for, never mind, Karen. I feel like all my jokes are really not very funny The comeback is decent because everyone always laughs on the comeback, but never mind. A joke book. You're a good man. Don't know if I would. Calculus goes so fast, I don't really have time for a lot of jokes, but so once in a while, I suppose. I try to have a few good stories from my children's past, and so like here's a good, this is a famous family story. My daughter's like, you tell that story every year. Like there's 3,000 kids walking around know this story. It's about my daughter. So so my daughter, if you ever meet her, she's kind of famous. Her name is Lindsay, and she married a young man whose name is Travis Lindsay. So her legal name is Lindsay. Same spelling and everything. So her husband, that's tough. When she went to get her marriage license, okay, the person at the window, right where she's filling out the paperwork, she hands it to the person. The person said exactly what Anna said. She's like, "Are you sure?" Says, "You must really like this guy." Oh yeah, perfect duplicate, mirror image. Yes, that's Lindsay squared. So the funny thing is that like in their ward and everything, her poor husband, they'll go like they'll be at some party or something, and they'll go, "Oh, I know, you're Lindsay." They get all excited, right? And, "Oh yeah, you're her husband." They don't even know his name. So anyway, the story, so, that's funny. Okay, moving on. That wasn't the story, but we'll tell the other story later because we don't have time. We got to keep going. Calculus moves quick. May 9th is coming up faster than you realize. Like I'm already getting nightmares. So, okay. I'm already nervous. It's only August. Okay. I don't even know what we're doing anymore. Questions? Please. It's a combination. It's not the 8 at all. Everybody look up. The 8 is just a multiplier. Okay, so the 8's not very relevant. But e, 2.72, to an exponent, if the exponent becomes more and more positive, that e raised, and the e isn't that important either, it's just some base. It could be 7 or whatever. That's going to grow in such a way that it's hard to believe it grows that fast. Here's 8e to the 2 times 47. That's the number. That's how fast it grows. But the opposite is also amazing to me, how fast it gets close to 0. This is negative 30. Okay, did I answer your question? Okay, anybody else? 2 for Harrison? Okay. Yeah, I will slowly migrate away from saying your name 13 times to give you points. I'll just start telling you. But initially, I'd say the name a lot to try and memorize it, and then I kind of shift to, "Oh, nice job, Maddie. Take 3 for that," something like that. I looked at Anna and said, "Maddie, sorry." My apologies. Look up. Now I feel bad. Questions? Awesome. All right, let's do another one. So, let's go to, where are we at here? Go to number 2 on the yellow. Two on the yellow. Okay, x is approaching infinity. We have to find the dominant term. Of course, I'm introducing another new idea because we throw up another new function. Right here's a power function. That's not new. Here's one you've seen before, but we haven't talked about it in this class. ln of x. Sorry, Taryn gets another point. We are comparing terms that add because x is approaching infinity. You just have to know how ln of x compares to that power function. So we turn to our friend Excel. Not really my friend, but it is helpful. Okay, this is not exactly the same things you're looking at, but it's enough to understand. Here's the ln of x function. Notice how it reminds me of the sloth in Zootopia. Slow. That was decent. Good reference. That is a good scene, that DMV thing. That's funny. That's a good one. Yeah, Kate's smiling. It's good. All right? That's a good one. Like he goes to the DMV, they're all sloths, like poor DMV workers. Never mind, I shouldn't laugh. Okay, maybe one of your parents works at the DMV. Now I'm going to get fired because it's all on video. All right, questions? We good? So Ellen goes really slow. So if you look back to this is going to become positive unbelievably quickly. Like it doesn't take hardly any x's before that's just huge. Multiplied by the negative 12, it's really negative, but then we add it to something that's not very big at all, the power function dominates. So memorize this quick, easy fact. When you're comparing things that are adding, and x is growing to infinity, ln grows really slow, then power, then exponential. So when you're comparing terms that add, that's all you have to remember. So this is going to become the limit as x approaches infinity of negative 12 x to the 100 divided by 3x to the 100. Questions? Cool. So now we do this thing, we factor and divide. So we get limit as x approaches infinity of negative 12 over 3, that's just negative 4. And we get x to the 100 divided by x to the 100. So we figured something out. As x is approaching infinity, please raise your hand if you can tell me what is the y-coordinate approaching. As x approaches infinity, Soraya, what is the y-coordinate approaching? Who agrees with Miss Hoover? Point. 2 for Soraya. Question. I went to school with a fellow named Chad Hoover. No relation. No. Not a Hoover's pretty complicated. I always ask because you never know. Like I one time asked a young lady, turned out that her uncle was my first cousin. And like he lives in Texas, so I never knew that would happen, but it was fun. So I was asked. Questions? Yeah, for reals. I'm not making it up, man. Oh, thanks, Anna. Well, that'd be funny to say. I'll just say that. It's like the whole class is just one big lie. Like, people go, yeah, Mr. Smith told the story. I never told that story. I just make stuff up and hopes it's funny, So. Questions? Questions? Okay. Hands up. What else have we found? Come on. What else have we found? Rachel. Horizontal asymptote. On the right or left side of the graph, Rachel? On the right. How many knew it? 0.2 for Rachel. Okay. So then you'd have to find the limit on the left as well. So let's write that. So the limit here is, let's see, limit's negative 4. There's a horizontal asymptote at y equal negative 4 on the right-hand side of the graph. You now go on your notes. You have good notes. In your packet, yellow packet, write this. The limit as x is approaching negative infinity of negative 12x to the 100 plus ln of x, all divided by 3x to the 100 plus x to the 99. Questions? Oh, please, Nate. Kate. Sorry. Perfect, Kate. Perfect. Yeah, all we're really doing, Kate, is we're visualizing. If we were graphing, remember, this is just a formula for finding y-coordinates. So if we were graphing, we would say, oh, as we go this direction, the x is going that way, the y value is getting very close to -4. So I don't know what the graph looks like. I just know there'll be y values that are close to -4. That's all I know. Good question. Anybody else? Awesome. Okay, they're trying to trick you again. They're trying to get you to forget that when you try to plug a negative number into this function, or you try to plug in 0, the result is undefined. You do not know what we get. It's undefined. We don't know. So you cannot find the natural log of a negative number, or 0. Therefore, there's nothing really to do. Like, you just stop. If you're making a graph of this, there's nothing over here. Like, from 0 this way, nothing. It's just big blank spot. So if you look at the answers, this way, here's the answer to number 2. That's it. Just stop. Question. You are expected to understand and have that memorized, that idea. Cool. Next one. Let's go back here. Let's go to number 4 in the yellow. So, clean this up real quick. Hold on. Okay, number 4 in the yellow. X is approaching infinity. You're supposed to find the limits. So please raise your hand if you can tell me what is the dominant term in the numerator. Looking for hands. What is the dominant term in the numerator? As x approaches positive infinity, which of those two terms will overwhelm the other as they are added together? About half of you. Let's try Katie. So 2 points for Katie. Your logic's very good. You're making a mistake as you reason through it. No big deal. Here's what's happening. The 10 really doesn't matter. It's just a multiplier, so I'll ignore that. So we've got e, and we have raised to -1, and now we're going to plug in values that become larger and larger. So we'd have something like that. We'd have something like this. So really, it's 2.72 being raised to a increasingly negative exponent. That's going to head to 0 really quick. Like, it won't ever equal 0, but it will get there fast. Does that make sense, Katie? Yeah. 2 points. Yeah, so the dominant term in this case is the 6. When they add together, the 6 is far more dominant. Questions? So raise your hand, please. If without doing any writing, you can tell me the value of the limit as x approaches infinity. Hands up. There we go. What's the value of the limit? Marielle? Raise your hand if you agree. Point 2 for Marielle. Questions? Okay, so now I stand here and hope that people start raising their hand. Why am I standing here waiting for people to raise their hands? Soraya knows. Good job, Soraya. Well done. Why am I raising my hand? Why are you raising your hand? Taryn. Right or left? Correct. So how many knew? Point. 2 for Taryn. So we've also found the horizontal asymptote. So if I were doing the homework, here's what I would do. I keep reminding myself, the goal is not to get my homework done. The goal is to test myself, verify that I am understanding the ideas. So if I'm testing myself, what I do is I wrote down the limit. That's good. I can check that in a moment. So I've got that. I would then write, as x approaches infinity, y is approaching 3. So there's definitely a horizontal asymptote at y equal 3. And that's on the right-hand side. Question. We need to check the left-hand side, so we rewrite the problem with a different limit now. So on your yellow packet, you write limit as x approaches negative infinity, 10e to the negative x plus 6 divided by 5e to the negative x plus 2. Process is the same. We're comparing terms that add. Please raise your hand and tell me which is the dominant term on the top, which is the dominant term on the bottom. For hands. Here we go. Getting a lot of people ringing in now. It's always fun to talk to each other. It doesn't bother me a bit when I ask a question like that. Just wanted it to make sense to you, Dallin. How many agree? Point for those that agree. 2 for Dallin. They're tricking you again because this is negative. Yeah, it switches back. The 10 doesn't matter. So we've got 2.72, that's E. And we've got a negative 1, and we're plugging in negative exponents. So it becomes positive, so this thing gets really, really big. Questions? Awesome. As always, right or wrong answer never matters. All that's important is we understand the why of everything. Yeah, it doesn't matter at all. So hands up. What's that limit going to be? Hands. There we go. So as x is approaching negative infinity, we still compare. We just find the dominant terms, and now the dominant terms are here and here. So we create a new limit problem. Looks like this now. Oops, negative infinity. Hands up. What's the limit? There we go. Ruth? Who agrees? Keep your hands up. Point 2 for Ruth. And we found another horizontal asymptote. As x approaches negative infinity, y is approaching 2. So on the left-hand side, there's a horizontal asymptote at y equal 2. Questions about anything? Please, Terry. Very good. Yeah, it's all about the fact that we really have E is 2.72. The exponent is negative 1 multiplying by whatever the x value is. The x value becoming increasingly negative, this becomes increasingly positive. Well said. Well said. Anybody else? Next one. Cool. Go to number 5, please, on the yellow. Go to number 5 on the yellow. Second to set up here. Okay, number 5 on the yellow. The more you think with me, the better prepared you will be for that test. So hands up, what's the first thing I'm thinking? Hands up, what am I thinking? My goal is to get you to just be able to think how I think, because doing it ain't going to work. So I got to think. Maddie?
Well, because it doesn't approach infinity or negative infinity, it's just not a cancel. I think there's like, we don't need 2 years later than we do for the factor 5.
You cannot say that any better. So just for the video, since I'm sure your voice will pick up on my mic, Maddie said, we do not have a limit as x approaches infinity. Skip that step. Go to this step. Perfect. How many knew it? Point. 2 for Maddie. Questions? Awesome. So we have to factor. So you should write this on your paper. Equals. Don't forget the equal sign. It's like forgetting periods on an essay. We factor. This is from a previous class. Questions? Outstanding. So now we see if we can divide. So we go like this. I hope I mentioned this last time, that you are not allowed to say the word cancel in this class. It's very offensive to me. I find it to be foul language. We've been tempted in past years to get out a swear jar and collect money for treats, but we haven't done that yet, but maybe. Questions? Okay, nothing canceled, but we did identify 2 factors that are the same. That's important. Okay, again, look, it's all about thinking, not doing. It's all about thinking, not doing. So you say to yourself, I have a formula here that can be used to calculate y coordinates. Here's a key difference. In this problem here, go back a couple. Come on. We started with this formula for calculating the y coordinates, and we modified it to this formula for calculating the y coordinates. Those 2 formulas are not the same, but as x approaches infinity, they behave enough the same that the limits are the same. But the 2 formulas, this formula and this formula, are not the same. They're different formulas. But in terms of finding a limit as x approaches infinity, they're enough the same. Here, problem number 5, we didn't do that. We factored, and we have exactly the same formula we started with. No difference. Just written in a way that's easier to understand. Question. Because now you can say, okay, this is a formula for finding y coordinates, but so is this. Same formula, but the red one is a lot easier to use. Watch. I'm supposed to plug in a number that is close to 2. It's got to be right and left. So a little more and a little less than 2. When I put that into here, I get some value on top, but the nice thing is I get the exact same value on the bottom. So nothing canceled, but this did divide to make 1. Question. Now I plug in a number that's a little more or a little less than 2 here. Raise your hand, please. What's the limit? What's the y coordinate? You can write that down. As x approaches 2, what's the y coordinate approaching? Hands up. The formula tells us this is how we calculate the y coordinate. As the x coordinate's getting closer and closer to equaling 2, hands up. What is the y coordinate getting closer and closer to equaling? For somebody new to call in here. All the new people dropped their hands. Half the room knows it, half the room is not very confident. Marielle, what do you get? Who would like to support Marielle? Point. 2 for Marielle. Who needs more explanation? Wave at me. There are several people that kind of waved. Give me a thumbs up if you are comfortable that the red formula is exactly the same thing as the purple. Okay? Everybody good? We're not going to plug in x equal 2. We're going to plug in a number that is close. But the nice thing is, whatever we plug in, this is going to be the same as this. So give me a thumbs up or thumbs down if that makes sense, that that's going to equal 1. Okay? All that's left to do then is say, well, we have 1 times whatever this is. So we're plugging in a little more than 2, like 2.01. Well, 2.01 plus 2, that's really close to 4. We also should probably plug in like 1.99. Well, 1.99 plus 2, that's really close to 4. This just gets multiplied by 1. Give me a thumbs up if that makes better sense. Okay. Go like this again if you're still feeling a little bit confused. Awesome. Okay, question. Okay, this is a trick question, but raise your hand if you know why I say it's a trick. What else have we found? Raise your hand, please, if you know why I'm saying it's a trick question. What else have we found? I'm trying to ask you a trick question, but I'm hoping you can raise your hand and say, oh, I understand why you say it's a trick question. What else have we found? We found the limit as x approaches 2 is equal to 4. What else have we found? Trick question. Harrison. Nicely done. So we did not do this limit. We did not find the limit as x approaches infinity. We did not find the limit as x approaches infinity. So we did not find a horizontal asymptote here. That's why I say it was a trick. Like when I say what else did we find, my thought is you're all going like, well, last time he asked that, it was a horizontal asymptote, but that doesn't really fit here. So that's why I'm not trying to fool you, just want to make sure you understand it. Questions? So we still have to go find the horizontal asymptote. So we have to do this limit, but you should be getting pretty good at that. Please raise your hand. I can change this limit question into something much simpler. What does it change to once you do the analysis? Hands up. Got one in. There we go. A few more. So we're taking the limit as x approaches infinity. That means we're going to compare terms that add. And we create a new limit problem. So what's the new limit problem that goes right here? Hands up again. What goes in the box? There we go. More. Amelia. Two points for Amelia. Put down a point if you had the same. Question. Please, Luke. Over here. Did you hear the gasp in the class? I said the forbidden word. You're okay. You're okay. Hey, listen. No. 2 points for Luke. This is a superb example of why the word isn't helpful. Is exactly what Luke just said. There's a third point. Luke said, there's 4. We're trying to get to 10 here. Luke said, there's 5. This game is deteriorating quickly. I don't know how to say it. That's the problem. Here I know exactly what to say. Look, you have something divided by itself. That's always 1. Okay? It's easy to say. Something divided by itself is 1. When people use the word cancel, they really lose track of what's going on. So like, keep going with your question, Luke. Are you saying to cancel here? Go ahead. I gotcha. You're doing really well. Let me show the answer to your question. Everybody watch his question. This is exactly why I have the sign. It really is exactly why I have the sign. He's saying, well, we started with this. The limit as x approaches infinity of x squared subtract 4 over x squared, x, my bad, x subtract 2. Is that correct? Did I remember correctly? Nodding is helpful. Okay. The proposal is to do this. Do the forbidden thing and draw a line through it, and then write this. Is that the proposal? Okay. Everybody look up. Find the flashcard. It'll help you remember. We built a flashcard last period that applies to exactly what's happening here. If you find the flashcard, I'll pay you a point. Which flashcard applies to this situation? What is it, John? What does it say? Perfect. Stay with me, John. So we're not canceling anything. We are looking to divide. We are looking to divide. So John, is this numerator made up of factors, things that multiply with each other? It is, but as written, is it made up of factors? No. Is the x squared a factor or a term, John? That's a term. Is the negative 4 a factor or a term? Still term because they're adding. It's x squared, no worries. Again, learning is all about you just talk until it makes sense. Don't worry about right or wrong. That's what the numerator is. It's 2 terms being added. Is that okay? So it's not what it says on your flashcard. You don't divide unless the top is factored. It's illegal. Like, this is wrong. I don't know how to say it. It just is. But there are millions of people walking the planet who believe it's right. And it's not. It's totally wrong. It doesn't work at all. It never works. It's just it feels like something you've done before, because too often all people are doing is canceling. Just drawing lines through stuff. Don't ever do that. It's like we always get to a place where we are dividing. Yeah, then it works. Does that help, Luke? You still feeling like, okay. Okay. Oh, got it. Okay. He's good. Moving on. Yeah, whatever. Here's a simple example. Look. Okay, if it were legal, watch. If canceling were a legal operation, I could do this. Are these two the same? No. This is where I make my standard joke. If you think that's the same, please bring me your wallet. I'll bring my wallet. We'll do some trading. So trade a little cash. So if you think they're the same, just saying, I'm going to end up very wealthy. Okay. Actually, moving on. Okay. Questions. Luke deserves a ticket because he's really good sport there. I'm not teasing you at all. You do know that, right? Okay, good. Because I really want you asking the questions. You have to ask. You have to do exactly what Luke did. You have to say, wait a minute. My understanding was this is a legal thing to do, and you need to ask about it so we can fix it. Yeah. Because it's super common. That's why I have a sign on the wall. Because everybody comes to this room saying, why does Mr. Smith do this complicated thing here? Like, I just always canceled. It was a lot easier. It was always wrong, but, whatever. So, questions? Sweet. We're over here now. Limit as x approaches infinity of that thing. So, as x approaches infinity, raise your hand please, what is the y-coordinate going to approach? Come on, pen. If this is the formula for calculating the y-coordinate as x gets big, what's the y-coordinate going to approach? Here we go. Haley? It's going to approach whatever x is, because this does now legally divide to make x. Because you have x times x, those are factors, divided by x itself, that does divide. You'd have this, as Haley said, the limit as x approaches infinity of just x. So if the x gets big, so does the y. Question. No horizontal asymptote on the right-hand side. If that were a negative infinity, because these are power functions, the comparison is the same. We'd end up in exactly the same place. So as x approaches negative infinity, raise your hand, please. What will y approach? Got to get you to do the thinking, not just watch. The idea is, if this had said negative infinity, we would have done exactly the same thing to get to here. Because when comparing power functions, the comparison is the same for positive or negative infinity. So we'd still have this. Which means we'd still have this. So what goes there? Hands up. That's better. Somebody new here? Isaac? No. Never mind. You're good. Sorry, I thought you were showing. Soraya? Louder, Soraya. Negative infinity. How many got it? Point two for Soraya. Questions? Please.
Okay, so when we're saying we're finding a limit in x approaching 2, right? When written in this format, we're not like limiting we're finding x when it's approaching 2 to the left and x approaching 2 to the right. We're finding an overall limit.
Good question. Okay, listen to Taryn. She asked, are we really finding the left and right limits? Please pay close attention to your flashcard. Your flashcard says, when you're finding a limit, the last thing you always do is find the left and right limits. So you're always doing that. We didn't write it out just to save a little writing, but we absolutely have to check left and right. So right at this moment, when we're checking to see what happens when x is approaching 2, oh yeah, I'm thinking 2.1. I'm also thinking 1.9. You have to check both, otherwise you do step into AP traps. They love to set those for you, where a student forgets to check both, they step in a trap. Yes. We said in both cases, the left and right limits are getting very close to 4. Hence, the overall limit is just 4. It's always about the left and right. We just didn't write it out to save some time. Good comment. Okay, look. I keep emphasizing, I'm going to keep doing it all year long. The goal of the class is to get you so comfortable with learning that you never care if you have the right or wrong answer. You just don't care. All you care is that you're thinking. Seriously, that's all that matters, is that like you just keep thinking. And if I tell you, oh no, that's not right, that's wrong, you're like, oh, what do I care? All I care is I get it right eventually. How many times I get it wrong along the way? No one cares. No one cares. Maybe I made this analogy, but I really like it. I have 10 grandchildren now, lots of little tiny ones, right? Okay, I have never seen a person tell a little 1-year-old. Like I have a grandson, his name is Becker, okay? His dad's the soccer coach, okay? So his name is Becker. So Becker just learned how to walk. Like he walks like this, right? You know, I'm a really bad actor. No one ever tells Becker, you walk really bad. Go back to crawling. You are much better at that. You don't do that. Like learning is about just learning. Who cares if you're right? Who cares if you're wrong? Just get good at talking about it. Does that make sense? Question. It's a really bad acting out there, Anna, sorry. Next thing, here we go. So we found the limit. We discovered there are no horizontal asymptotes for this one. If you look at the answer to number 5, the answer will confirm that so that you can know that you are preparing yourself well for the test. Like that. So, questions? Awesome. Okay, let's do another one. Let's go to see where we at. Which one? 3 on the pink? Yeah, we did the same concept, Taryn. So I think you'll be okay. 6 on the yellow. Just real comment on the pink. So 3 on the pink, x is not approaching infinity, so we're going to factor and divide. Yeah, and then once you factor, as long as you're not trying to cancel anything, it really does become clear. So I think you'll be okay. Which one did you say, Chris? I can't hear. 6 on the yellow, Hannah. I'm going to do one step, and then I'm going to, we'll try it, whatever. Hands up, what's the first thing I should do? Hands, come on, think with me. What is the first thing I should do? Just go straight down the flashcard. Julian. Factor, x is not approaching infinity, so we do not look to compare terms that are adding. I'm just updating my board here. We do not look to compare terms that are adding because x is not approaching infinity. So we go to the next thing, which was to factor and divide. So I write the limit as x approaches negative a. Okay, you need to get used to this. One of the favorite tactics on the AP test is to create questions that use extra letters. I don't know how else to say it. Because they know that all students freak out. True? Yeah. As soon as there's more, all the students are thinking, I thought X and Y were plenty. Why do we got to throw in an A and a B too? You know, it's true. It's because look, freaking out is normal because it is more difficult. I'll be straight up honest. It is. When there's more letters, it's harder. But they love to do it. It's really common. So I'm going to try and get you used to it. Okay. It does not change how you think. You still have to factor and divide. So I look at the numerator and I remember from a previous class that anytime I have a difference of squares, I can factor. Like that. Question? Now we don't do this. That's forbidden. It's like a scene from Lord of the Rings, the name that shall not be mentioned. Never mind, bad jokes. Okay. Harry Potter, dang. No wonder I messed it up. The good thing is I messed it up on accident, so it's even funnier. Okay. Maddie's like, wait a minute, it's the wrong movie. This is like the name would not be mentioned or something like that. He shall not be named. This shall not be said. Thank you. Good. Okay. Wow. So let's see. X plus a divided by x plus a. I can promise you there is so much in math that people mess up because they never really thought that all they were doing was something very simple. Because people thought they were canceling, they completely lost track of the fact that they're doing nothing but dividing. It's like higher math is just lower math. It's not that much more complicated if you think of it the right way. So as x gets close to negative a, that red box is 1. Now we do Terran's thing. You plug in an x that's close to negative a. What's negative a plus negative a? Yeah, but minus is the same thing as adding, right? Like I can say negative a plus negative a. It's the same thing. Does that make sense? But it's easier to think of it this way, because what's negative a plus negative a? There you go, negative 2a. It's simple if you think about it the right way. So all I'm trying to do every single day is just get you to change how you think about it. And then it's easy. So the limit here is negative 2a. Because you'd plug in a little more, a little less. I gotta hurry because the bell's gonna ring. Okay, look at me. We have to stay on target for May 9th. And they're messing with us this year because they only give us 55 minutes on Wednesdays. That's a significant challenge, we'll call it. So today, as I mentioned at the beginning, I tried to do as many homework problems as we could together so that your homework load is not too much. But the homework is both packets, okay? The pink should go pretty fast now because of the things we talked about. Now look at me, look. I do a lot of writing on the board so you can see how I'm thinking. As you're doing this packet, don't make it busy work. If you can do things in your head, it's fine. Just make sure you're writing down the answer and then checking to make sure you're not tricking yourself. So good job, you guys. Good work. Yeah, so stay with me as long as we're here. So Taryn, we found the limit as x approaches negative a. Are you comfortable that we did find left, right? Awesome. Okay. So if I'm finding this limit as x approaches infinity, now I'm back to trying to see if I can find a dominant term. So what's dominant in the top? Right, because the a, per the AP rules, represents some number that we don't know, but it's fixed. It's like 7. Well, not exactly. The a is a fixed value, like 100. The x is going to grow forever. So that's why the x is dominant. Does that make sense? Good job, Tim. You're welcome.